Hi, this is Victoria from crushcrypto.com. In this video, I will be discussing Layer 2 blockchain scaling solutions, in particular sidechains. This is the second video on Layer 2 scaling solutions in our educational series. If you're interested to learn more, check out our video on state channels, which is another Layer 2 solution. A sidechain is a unique blockchain that is attached to a main chain using a two-way peg. Sidechains allow tokens and digital assets from one blockchain to be used in a separate blockchain and then moved back to the original chain if needed. Sidechains are independent from the main chain and are responsible for their own security. This means that there needs to be a mechanism in place to achieve consensus while protecting from bad actors. Their independence also means that in the event a sidechain is compromised, it would not impact the operation of the main chain, which is an important feature. Sidechains are a promising Layer 2 scaling solution because they allow for transactions to take place off the main chain, similar to state channels. Users can send funds and use decentralized applications using sidechains. This takes pressure off the main chain, allowing it to operate faster and cheaper transactions. While sidechains resolve some of the issues that are impeding blockchain scalability, there are still things that need to be worked out before they can be implemented as a widespread solution for scaling. Because sidechains are independent from the main chain, there are security concerns about mining power as well as easier attacks. Another issue is that sidechains add another level of complexity to blockchain technology for new users, which could affect adoption. There are also unanswered questions about what exactly would happen to assets in the event of a sidechain being compromised or failing. There is a lot of ongoing research right now to look at providing more security to sidechains using various methods. This diagram is a simple visualization of a sidechain working with a main chain. As I mentioned earlier, sidechains are independent blockchains responsible for their own security. They are simply connected to a main chain through a two-way peg. For networks using proof-of-work consensus mechanisms, each sidechain needs to have miners. For those using other consensus mechanism, then each sidechain will need block producers or validators. They can interact with the main chain, but what happens to the sidechain does not directly impact the main chain, and vice versa. To trade assets from the main chain to the sidechain, a user needs to send their assets on the main chain to a specific address that locks up the funds. After the transaction is confirmed, a notification is sent to the sidechain, and a certain amount of sidechain assets are then credited to the user. To trade assets from the sidechain to the main chain, the process is reversed. Some sidechain implementations may utilize some kind of federation. A federation is a group of servers that act as an in-between point between the main chain and the sidechain. Federations decide when a user's coins are locked and released, and sidechain developers can choose members of the federation. Most federation designs are not trustless, so there is a risk of centralization depending on how the federation is designed and selected. One prominent implementation of sidechain technology is Plasma. In August of 2017, Joseph Poon and Vitalik Buterin released the first draft of the Plasma white paper. In the white paper, they described an Ethereum scaling solution which is scalable to a large number of state updates per second, potentially in the billions. This would enable the blockchain to represent a significant amount of financial dApps worldwide. Plasma is a framework for the creation of sidechains called child chains that interact with the Ethereum blockchain. These child chains can have their own child chains, which themselves can have more child chains, and so on. Plasma can be thought of as many branching blockchains linked to the main Ethereum blockchain. The structure within the Plasma framework can be thought of as a hierarchical tree of sidechains that conduct transactions and computations on their own. They may also periodically transfer information to the main chain. The benefit of having this structure is that developers can run entire applications on child chains operating at faster speeds and lower fees than the Ethereum blockchain itself. To create a Plasma child chain, a smart contract is created and deployed to the Ethereum main chain. This smart contract contains the rules and state hashes of the child chain. It also contains a two-way peg that allows users to transfer assets between the main chain and the child chain. When a child chain is up and running, the block creators must periodically send information to the main chain. This is done in order to prove the validity of the child chain based on its consensus rules. There are already a number of blockchain projects that are working on sidechains at the moment. I will go over some of these projects briefly. RSK is an open-source smart contract platform. It features a two-way peg to the Bitcoin blockchain that also rewards Bitcoin miners through merge mining. This encourages miners to actively participate in smart contract resolution. The goal of this project is to add functionality to the Bitcoin ecosystem by enabling smart contracts, near instant payments, as well as higher scalability. Matic Network is a decentralized platform that uses an adaptive version of the Plasma framework. Some of the network's features include account-based Plasma, a decentralized validator layer, and a focus on user experience. Loom Network is a network of sidechains connected to Ethereum that use a delegated proof-of-stake consensus mechanism. These sidechains allow developers to build highly scalable games and user-facing decentralized applications that are backed by the security of the Ethereum blockchain. Liquid is a production sidechain and inter-exchange settlement network for Bitcoin. It uses a federation as nodes that was created by Blockstream. The goal of this project is to improve capital efficiency and market liquidity by facilitating rapid and secure transfers between accounts at participating exchanges or brokerages. After 102 confirmations, which is around 17 hours on the Bitcoin blockchain, the synthetic Bitcoin LBTC on the sidechain is transferred to the user. OmiseGO is building a public, currency-agnostic, decentralized exchange network. The network will be secured by Ethereum and built to scale using Plasma architecture. The OmiseGO network will be able to interact with Bitcoin and other blockchains. The network is also being built with a high capacity for scalability in mind. POA Network is an Ethereum-based platform offering an open-source framework. The platform aims to provide easier, cheaper, and faster execution of smart contracts. It is a sidechain to Ethereum that uses proof of authority as its consensus mechanism. Thank you for taking the time to watch this video. If you haven't already, please subscribe to our YouTube channel, follow us on social media, and join our Telegram group to receive our latest in our educational series as well as other updates. The invite link to our Telegram channel can be found in the video description. See you again next time.